We did it! Haha! Now that we have used up all our good karma on making sure the live stream works, hello and welcome back. We are on Excel Day 2. The topics of Day 2 are going to be exploring the basics of formatting data and analyzing sets of data that are parsed out from one another. That will make up what you need to accomplish homework assignment number 2. Then on Day 3, we're going to talk about aggregation in general in a couple of different ways, both pivot tables as well as some of the various ways that you can apply array functions to aggregate data. Day 4 will go into more complex analysis from data that has been aggregated. Day 5 will be dedicated primarily to iterative calculations, things like FEA, etc. So here on Day 2, the primary purpose is going to be talking about ways to work with data. And I think the easiest way to start that would be to jump back into this example problem from last Thursday. So far, we had collectively calculated what each student's current grade in the class was and determined a letter grade corresponding to that grade, right?
Yeah.
Well, let me ask you a question. Which student has the highest grade in the class? George. We know that because the highest percentage under current grade is 85%, and we can read that that student's name is George Orwell. Well, that's all well and good for 5 students, but as we get more students, it might be harder to parse through this. Now, granted, as a result of formatting this as a table, we gain some superpowers associated with it, like, for example, the ability to sort it. I could say sort largest to smallest, but if I wanted to programmatically grab out the name corresponding with the student that performed the best, there are functions for that sort of thing. Do you know what function will pull out the maximum value from a range? It's called max. So let's say I wanted to figure out what the highest score in the class was. Highest score. And I applied the max function to that. So I can say, use the max function and grab the data from current grades. Like we had talked about on Thursday, you can select multiple sets of data within a function by identifying individual cells. Like, for example, I could say Q2, comma, Q3, comma, Q4, comma, etc., etc. Or I could indicate that I'm applying a range with the colon. So I could say Q2 colon Q6. That would also work. I could click and drag like this to select multiple cells in a row. Or, for the case of tables specifically, I have an additional superpower. That superpower is if you highlight over a column, specifically over the column title, but not so far up as to highlight the entire column itself. So we're looking for this sweet spot. We go above the header, here. Not here, here. That specific spot will click all of the data within that column. So if we said quiz subtotals, this would return the maximum value from the quiz subtotals. If I said maximum value from current grade, it'll return the maximum value from current grade. So if I just apply that function, it'll return whichever percentage is the highest. That is the value that we see as 85%. If I format it as a percentage, I can see that a little bit more clearly. That's the highest grade. That's all well and good, but that's not the question that I asked. The question that I ask is, which student has the highest grade? So we are taking a set of data, we are going into it, and we are trying to retrieve a certain value. That concept in Excel is referred to as a lookup. And there are lots of different ways to perform lookups, depending on which circumstances you find yourself in. Right now, we are looking for a specific value. For that, we are going to go into a range. We're going to select which value corresponds to what we're looking for. We're going to take that index, apply it to another range, and return another value. So let's break that apart into pieces. First thing I want to do is use the match function. The match function will go find a certain value in a range and return the index corresponding to it. When I say index, I mean position. So if I told it to go find 85, because these are sorted from highest to lowest, that'll return position number 1. If it was sorted like this, that same function would return index number 3. Note, Excel, like most Microsoft products, starts its indexes at 1. For those of you that have taken computer science classes, that's, of course, incorrect. But it's okay. We make do with Microsoft when we have to. So match, we're going to go look for something and return the index corresponding to it. The first argument in this function is the thing to find. So what I want to find is the value that is currently in cell S11. Where I want to go looking for that is the exam scores, the overall grades. The third argument is how precise to be. I can find the closest value, I can look for an exact value or fail, or I can go up or down to the next highest or next lowest value. So right now we're looking for a specific number because we got that number from the table. We know it exists. But if you were working for a company that spec'd out pumps and you need to go into a big lookup table and figure out which pump had the required power to accomplish whatever it is you're trying to do, you probably don't have a pump that matches the exact power requirement that you have. You're probably going to go into the table and find the next highest power output, right? That is the sort of situation where accepting a relative error is okay. What we want is an exact match, so I'm going to put 0. Not to be confused with 10. So we're using the match function to go find a value in a range and return an index corresponding, looking for an exact match. When I hit enter, it should return 3. Are you ready? Yay! The reason that having that value is useful is because we have another function called index. Index will take a range and return the value in the range corresponding to a certain index. So I could say equals index, and now I read, the first thing it wants is the thing to go pull from, the range for which we are looking for a certain index. So I'm going to go hover above the name column until I get to the sweet spot right here. I'm going to click it. We're selecting all of the name data, comma. Now, which row number do we want? 3, right? If I say 3, it'll return George Orwell. If I say 4, it'll return Matthew Archimedes, etc. If instead of applying an actual number, I give it cell S14, now it'll return the name corresponding to this score. Does that logic make sense? So we are first finding the maximum value in the overall grades. We are looking up the index corresponding to that value. We are looking up the name corresponding to that index. If I were to change highest score to lowest score, this automatically permeates. If I sorted the data so that it was in a different order, the index position changes, but the name doesn't. It's done automatically. It's much more better. Does that make sense? Now, wait, I hear you saying, but John, we did that in 3 cells. Surely there's a better way, right? There is. We don't need to split this into individual calculations. It's useful for the purposes of explaining how this works, but in reality, what you would want to do is put them all into one function. So we would say index, and then instead of specifying the value of S14, we would say match. And what we want to go match is this value in S11, looking for that specifically in the current grade column, specifically looking for an exact match. And better yet, instead of S11, I can actually just type max current grade, and we have George Orwell without all the additional steps. Does that logic make sense? Okay, I will pause here for a second. Do you have any questions so far?
Can you redo that sequence?
Sure. So the easiest way to start this is to start with the last function and then work your way in. So my last function, the thing that runs last, is the index function. The index function takes 2 arguments. The first is the range to go looking for something. The second argument is the row number or index corresponding to what we want to retrieve. Note that index can also take 2-dimensional data, and we can give it a column and a row, but right now we're just giving it a 1-dimensional vector. So instead of S14, what I'm wanting to give it is the value that's currently in cell S14. So this function that returns the value that we wanted is what we're plugging in here. And we're following that same logic to, instead of grab a value from cell S11, we want to grab the function that returns the value that's currently in cell S11. That function is the max function. We're looking up the maximum current grade. By the way, while we're here, this whole function reading is kind of brain breaking at first when you're first starting to get experience with Excel. If you want, you are welcome to break it into multiple lines. The way that you do that is by dragging down the bottom edge of the formula bar and using Alt-Enter to break it into lines. So if it makes it easier for you to format something like this, I mean, you can totally do that. Spaces are ignored. So I could do something like this if I wanted to. Now, there's pros and cons, because now I have to look a little bit harder at what I'm doing with some additional effort to format it. It also has a tendency to break anytime you open it on a new computer. But when you're building it for the first time, it's sometimes useful to some people. So if I wanted you to go calculate, let's say, the highest score in the class, let's just format a bunch of these so they're big enough to have multiple values. Let's say I wanted the highest value, the lowest value, and then just for funsies, maybe like the second highest value. I mean, maybe we don't want the highest score in the class, we want the second highest score in the class for some reason. Or more accurately, maybe we want to drop out an exam from the student's calculation. Second lowest or something or other. Well, just for completion's sake, let's say we wanted the highest value, the lowest value, the second highest value, and the second lowest value. So I'll take this same function that we used to build our George Orwell response, paste it into the maximum value, because that's what we wanted already. Under lowest value, I can say min instead of max. So maybe this should be highest score and lowest score. Second highest score and second lowest score. So max returns the highest, min returns the lowest. You know what function returns the second highest? It's a function called large. Large returns the nth largest value in a set. So if I were to replace max with large, and then add a comma and a 1 to the end, it's going to return the first highest value. So right now, this should still be George Orwell. That's the first highest value. I could replace that with a 2, and that would be second highest. I could replace it with a 5, and it'd be the lowest because we have 5 students in this class. Similarly, small works the same way, except from the opposite end. So small returns the nth lowest value. First would be the lowest, second would be the second lowest. 2 here is going to return what I want. So if for some reason I was looking for the highest score, the lowest score, the second highest score, and the second lowest score, I could do it this way. Index and match are extremely powerful lookup functions. They are the equivalent of building what you need for the circumstance in front of you. There are a couple of other lookup functions, and they work based on common circumstances. So if you were in a circumstance where you were specifically looking for a value in the first column, and you wanted to return something that was in the same row but from one of the columns to the right, that lookup return process would be inside of a function called VLOOKUP. VLOOKUP is a shorthand for returning a value from a different column within the same row as the thing that you're looking for, and the thing that you're looking for has to be in the leftmost column. Very specific circumstance, super convenient function. Similarly, if you were looking for something in the first column, so you're returning a value from the same column after finding a value in the first row at a different position that is vertically aligned, that would be HLOOKUP. VLOOKUP and HLOOKUP are named because you're finding something that is vertically aligned is what you're looking for, and horizontally aligned is something else that you're looking for. Very specific tool for a very specific circumstance. But you know what's better than knowing VLOOKUP and HLOOKUP? Is knowing index and match. Because you can build whatever you need, including the same functionality as VLOOKUP and HLOOKUP, using index and match. Now, if we were to imagine a circumstance where we were looking for something, say, in the first column of a set of data, and we wanted to return something else from the same row, you can imagine a circumstance where maybe I'm asking a question like, what is George Orwell's current grade in the class? Well, students aren't identified by their name. Students are identified by their student ID number. So for all intents and purposes, you guys are data associated with a student ID number. In this table, the first column is a student ID number. So we were in a circumstance where we wanted the current grade corresponding to a certain ID number. VLOOKUP is what we want. Or, better yet, it's easier for us to sort data into multiple tables and pull what we need based on a student ID number. So to try that, let's consider a situation where grade data and roster data were located in two separate tables. For that, I'm going to go into content and I'm going to download a specific set of data. That would be dummy grades and dummy roster, both from Excel Day 2. And what I want to do next is import them into an Excel workbook with one on one table and one on another. Specifically, I want roster on the first sheet and grade data on the second sheet. Let's just arbitrarily decide. So I'm going to open up Excel, and then I'm going to go into my first sheet, which I'm going to name something like, oh, let's call it roster, shall we? And I want to import the data that's in the roster. You guys remember how I import data? Correct. We go to the Data tab. From text. Now we go find our text file corresponding to roster, dummy roster, Excel Day 2, import. Is it delimited or is it a fixed width? It's delimited. Delimited refers to the fact that there is something that is delimiting each set of data from each other. The thing that's delimiting in this comma separated values table is a comma. So I want delimited, it has a header, I can leave it, comma, good enough, place, and we're done. I'm going to highlight this, format it as a table, so that I gain the superpowers associated with formatting it as a table. It'll prompt me, hey, do you want to break your link to the external data? I say, yes, I do, Excel. For those of you running the Office 365 version of Excel, it does that automatically as part of the data import process. I'm going to further take this another step by naming my table. It's called Table 1 by default, but I could give it a name that allows us to reference it or the columns within it by name a little bit more conveniently. What would you like to name this table? Done. Table 1. Real convenient. Now I'm going to create another sheet, and we're going to place the grade data into this table. So I'm going to go up to Data. I'm going to click From Text. I'm going to click Dummy Grades, Import. Delimited has headers. Comma is the thing that separates. Finish, Place, Highlight, Home, Format as Table. Break the link. Give it a name. What would you like to name this table?
Bobby.
Bobby. I like it. So, because we've chosen sarcastic names, it's going to be a little bit more confusing, but the advantage of naming a table in general is that you have the ability to reference columns from that table, knowing what you actually want. I will also point out that when you are trying to remember the name of a table that you used before, if you start to write it, Excel will prompt you to autocomplete it, and you can just hit Tab to autocomplete. So, we have two tables, one called Bobby, one called Table 1. In Bobby, we have student IDs and homework and quiz scores and exam scores corresponding to each of those student IDs. In roster, we have all the roster information. So name again, and then let's say class, math enrollment, and retaken class. So let's say that I wanted to build a third table. And my third table is going to take a student ID. It is going to grab their name. It is going to grab their class. It's going to grab their math enrollment, their homework 1, their homework 2, and you know it's better than trying to manually keep track of which homeworks we're importing. Let's just keep it going. So we had 5 homework scores. Yes, we did. Maybe a quiz 1 and a quiz 2 and a quiz 3 and an exam 1 and an exam 2 and an exam 3. And then I'm going to calculate a homework subtotal, and I'm going to calculate a quiz subtotal, and then I'm going to calculate an exam subtotal, and maybe a current grade. So for each student that appears in the roster, we're going to return their name, their class, their math enrollment, and all of their raw grades, and then we're going to use that to calculate a homework subtotal in the same way that we did before. Quiz subtotal, exam subtotal, and then a current grade. Are you following the logic so far? We can make more tables. We have access to other stuff, but at this point I'm out of room on my table. Next thing I'm going to do is grab all the student IDs, because I want all of this data for all of the students to begin with. Third, I'm going to format this as a table so that I gain the superpowers associated with formatting it as a table. I hesitate to ask, what would you like to name this?
Johnny V. Gradebook.
Thank you. Gradebook is going to be all of the information that we could possibly need for calculating whatever it is that we need for the circumstances. If I'm assigning final grades, if I'm posting stuff on D2L, whatever, it's all here. The convenient thing about this is that this is a metadata table. It doesn't contain any raw data in and of itself. It's built entirely, dynamically, from this other data. Are you following that logic? So if you wanted to, you could calculate grade information without seeing the students' names, so you can do it a little bit more anonymously. If you wanted to build grade data based on a link from D2L, you could do that here. If you wanted to have the grade calculations done in MATLAB instead of Excel, because you wanted to do a couple extra statistical calculations, you could do that. Breaking it apart allows modularity. Anyway, first thing I'm going to do is I'm going to take the student ID number 8675309, and I want to go look in roster for a name corresponding to that value. I could build a lookup function for that. I could. I have the skill set. I have index and match. The world is my oyster. But this falls into the narrow set of circumstances for which there is a Swiss Army solution. That Swiss Army solution is VLOOKUP. I want to go into my roster table, which is incidentally called table 1. I want to return the value from column number 2 corresponding to a looked up value in the student ID column. Are you following that logic? Yeah, John, we totally get it. Okay, cool. So under sheet 3, I'm going to go VLOOKUP. VLOOKUP takes 4 arguments if I want. The first argument is the thing to look up. Student ID is what I want. Note, because I'm formatting this as a table, I can reference the value from the current row's student ID column with this notation. That's the power of tables. If we were doing this manually with just arbitrary cells, we could be like A2, absolute reference, and that would work just as fine as well. Next argument is the array in which to go look for something. So I'm returning a value corresponding to a certain column in a different table. The table name is, of course, table 1. You'll note I started to type the word table 1. It's auto-completing for me. I can hit tab, and it auto-completes. That's super convenient because all of your tables are super name sensitive, and if you're in a circumstance where you're just arbitrarily uppercasing and lowercasing letters, you can forget that sometimes. I personally prefer camel case for my table names, so they start with a lowercase letter, and then each additional word becomes an uppercase letter, but I left table 1 just as an all lowercase as an exercise for you guys. So the next argument is, which column do you want to return? So which column was name in? That's right, it was 2. So I'm going to type 2. Lastly, just like before, we get to choose if we want an exact match or not. Do we want to accept the closest student ID that it finds, or do we want to only accept an exact match? We only want an exact match. We don't want to find a student that happens to have a student ID that's close to a different student. That's unacceptable for these particular circumstances. So we have VLOOKUP, student ID, table 120. When I hit enter, it should populate with all the names. Hooray for us, we did it. Would you like to do it again? Let's do it again, hooray! So under class, what's going to be different? It's going to have 3. Specifically, we're returning a value from a different column. We no longer want 2. 2 will still work. 2 will return name again. But under roster, I see that the class column is the 3rd column. So what I want is 3. So that gets the class. Under math enrollment, I could do the same thing again, except this time I want 4. So I know what you're thinking. You're thinking, John, why did we just build the table that we already had as a table? Because we are only using student IDs. Everything else is dynamically populated from a source set of data. So if we were in a circumstance where we only needed, like, I don't know, 3 students or 2 students, if we only have those 2 students' student IDs, it'll only populate for those 2 students. And the roster data is set somewhere else one time. And we can reference it as many times as we want. Okay, now for homework, quizzes, and exam scores, we're going to do that same process again. We're going to use VLOOKUP, and instead of table 1, we're going to use, what was it, Bobby? Bobby. Furthermore, I want homework score 1, which is in column 2, so I'm going to use column number 2 for that. So far, so good. Now, I find myself in a circumstance where I could just import the raw data as it is. But since I'm here, I have the ability to do more things to it if I wanted. Like, for example, if the raw numerical score isn't indicative of what I'm actually trying to communicate with my table, maybe percentage would be better. I could VLOOKUP the value, divide it by 10, and now I have a percentage. It still contains the same information, just now it's expressed as a percentage. That might be more or less convenient depending on what I'm trying to do with the information. Does that make sense? Okay. Now let's try an experiment. We talked at length last time about the advantages and disadvantages of grabbing this little box in the bottom right-hand corner and dragging around arbitrarily. If I were to grab the bottom right-hand corner of this cell and drag it to the right, Excel is going to try to predict what it is that I want to propagate. Absolute references, that is names, are going to stay the same, but relative references and numbers could be changed. So if I drag over to the right, you'll notice it breaks. The reason it breaks is because student ID here has shifted over. That name is a relative reference. So that isn't going to be good enough for my circumstances. However, if I copy the value in this cell, highlight across these other cells, and right-click, one of the options that's available to me is paste the formula. Paste the formula will just paste this same formula over and over and over and over and over again without trying to do any of the auto-population prediction nonsense. That's really specifically useful for this particular circumstance and other particular circumstances that are similar when you're doing data analysis. Now, I could go through the process of maybe changing this to 3, and then changing this to 4, and then changing this to 5, and then changing this to 6. But that's a bunch of typing. And I don't want to do typing. I'm not here to type. What I'm here to do is build something that works better, right? So take this particular circumstance. If I were to break out the column that I'm referencing, say down here, maybe this is column number 2 in that other sheet, 3, 4, 5, 6, 7. I could go grab that value from a relative reference, like that. Does that make sense? So I could go grab the value from this cell before performing the lookup. Or, my particular favorite way to do this is, there's a function called column. The column function returns the number corresponding to the column that you're in. So if you're in column A, it returns 1. If you're in column B, it returns 2. If you're in column whatever we are in now, I'm going to guess E. If we're in column E, it's going to return 5. So if I were to take column open parenthesis, close parenthesis, minus 3. It's going to return 5 for column E, subtract 3 from it, and return a 2. Plug that into the VLOOKUP function. And now, when I copy and paste that, I know it didn't look like much changed, but they did change. They're now no longer the first homework assignment. That's pretty neat, right? Cool. So, whatever the case, using whichever method you prefer, you can go about changing all of these. What are we on, like 7 now? No, it can't be 7. It's got to be 2, 3, 4, 5, 6, 7. Okay, so I could take 7 divided by 50. I could take 8 divided by 50, do all this manual labor. 9 divided by 50, 10 divided by 100. This much labor, I'm basically a coal miner, I'm pretty sure. Should get incident pay, but I don't. I'll just make do. So 11, 12, 10, we got it. And then I'm assuming that you guys have got this part down because we've done this a couple of times now. I'm going to take the average of the homework scores to get a homework subtotal. I'm going to take the average of the quiz scores to get a quiz subtotal. And the average of the exam scores to get an exam subtotal. Like this. And you'll note that I don't have to do the divide by 10, divide by 50, divide by 5, or whatever nonsense, because what I'm doing is calculating the average of a percentage. That's pretty neat. Then let's go determine a couple of letter grades again. Okay, nope, we don't want VLOOKUP. Got all used to it. If exams, no, current grade, sorry, I got ahead of myself. What I want is 0.1 times the homework subtotal plus 0.15 times the quiz subtotal plus 0.5 times the exam subtotal, all divided by 0.75. Change these to a percentage, and there we go. Bunch of data expressed as a percentage. Were you going to ask a question, or were you just holding up the propel? Cool. So the reason that it might be useful to indicate all of these values as percentages is, first of all, it made the calculation of the average more convenient. You can also do some fun stuff when you have normalized data like this. Like, for example, if I wanted to color code my table, I can color code my table. By going up to conditional formatting, I can indicate maybe a color scale to this. Apply the highest value in the table with the color green, the lowest value with the color red, and everything between on a scale from red to green. Or if I wanted to, I could highlight all of the cells that were below 50% and highlight them as a red. Or if I wanted only the 100% to be marked as a blue, or whatever. I can do that with conditional formatting. Now, we built this table so that we can have our next conversation. That next conversation is based on the concept that sometimes we want to perform calculations based on a different value than the thing that we're performing the calculation on. Like right now, we have math enrollment information. We have some students in Math 102. We have some students in Math 115. We have some students in Math 123. So let's say I asked a question like, what's the class average of all the students who are in Math 123? Well, we could sort the table with our superpower, tell it to only show values for people in Math 123. And then we could do math on this current grade manually like some sort of peasant. But there's a better way. So again, in this circumstance where you're doing a calculation on a field based on the value of another field, we employ the if statement and the function statement together. I know. Since what we want is an average if the math enrollment is a certain value, the function that I use is average if. So let's say I want average based on math, and I want Math 123 as my first option. So I'm going to go into my function. I'm going to use average if s. So I'll pause. Average returns the average of stuff that you feed it. Average if returns the average if that value meets a certain criteria. So if I wanted the average of everyone that placed above a 50%, I could do that with average if. Average if s performs an evaluation on a different column. I know that's a lot to process. We'll just do it one thing at a time. The first argument in the average if s function is the range to average. So I want to go grab current grade. I'm going to highlight above current grade, but not so high as to highlight all of s. Boom. Then I'm going to hit a comma. The next thing it wants, the next argument, is the range on which to perform the evaluation. So what I want is math enrollment. Boom. The third argument is the criteria to evaluate. So what I want is quote equals math 123 unquote. And then I can close my parenthesis. So what I'm doing is I'm feeding it a string, a sequence of characters, and that string is the thing that's evaluated when it performs the evaluation against the criteria. So equals math 123 will return true if the value in the criteria range is math 123. Same page so far. Now when I hit enter, the average for everyone that's currently in math 123 is at 51.2%. Again, pausing. Is that making sense? Okay. I'm now going to add another wrench to it. You guys will have noticed I don't like to type things. I don't want to type equals math 123. I don't want to have to change that for every value over here. There's a better way. Okay. That better way is the concatenate operator. Have you guys heard that word before?
No.
Do you know what concatenate means?
Probably something to do with Excel.
Okay, well, concatenate actually has meaning outside of the scope of just Excel. We could go Google the word concatenate if we wanted to, but for our purposes here, what we're going to do is take two things and merge them together. Like if I had the dog ate beans. I could grab the value from cell K17 and merge it together with the value from cell L13. To do that, I would use the concatenate operator. The concatenate operator is ampersand. So K13, oh, no, 17? Yeah, K17 ampersand, L17 ampersand, M17 ampersand, N17. We'll grab the dog ate beans, merge them together, and return the result, which is, of course, the dog ate beans. I could space out those words by adding in a string with only a space character, like this, if I was so behooved to do that, like that. And now I get the dog ate beans. Similarly, over here, instead of typing equals math 123, I could just say equals ampersand the value in the cell that is immediately to my left. Whoa, right? Now when I hit enter, it's going to return the average from current grade for this math class. So now I could say math 102, and I don't have to go change my function. Check it out. Copy, right-click, function. Express as percentages. Does that logic make sense? So the class average, based on the current grade column for everyone in Calc 1 is a 51.2%. For everyone in Pre-Calc, it's a 78.2%. Interessante. Now, what would be different if I wanted class average based on class enrollment? Maybe I want to know how the sophomores are stacking up against the freshmen. Maybe something like freshman, sophomore, junior, senior. What's going to have to change in this function? The column corresponding to my criteria range. So I'm just going to copy and paste that function. And instead of math enrollment, what I want is class. Not CC, class. Now, it's looking for R15. So I really should have copied and pasted the function as opposed to just bringing it down, but it's fine. So the class average among students based on their class I have a freshman average of 77.5%, sophomore average of 68.8%, junior average of 43.9%, and a senior average of 51.1%. There are going to be lots of circumstances when you guys are analyzing data where you need to perform a calculation based on a value in another cell. If S is the thing that allows you to do that, there's an average if S function. There's also a sum if S function. There's also array functions, which are similar, but the topic of Thursday's class. Do you have any general questions before we break? I will point out that your homework assignment this week is way easier than the stuff that we did in class today. I don't want to ramp up the difficulty too fast, too quickly, so it's a bunch of easy questions like, hey, that thing that we did at the beginning of class, do it again. And then, it looks like my image is broke. That's interesting. Well, I'll fix that PDF and post it. See you guys on Thursday.